we also have an alternative form of the cosine law, and this alternative form can be used in order to find an angle. And so this form of the cosine law is used when we have three sides and no angles. So three sides and no angles. And that triangle, you could say, with given information, is side, side, side. And so if we do have this alternative form, then we can convert a squared is equal to b squared plus c squared minus 2bc into cosine a, and this can be rearranged to something like this. And how we would do that is, first of all, I would have to subtract a onto this side. And so if I do that by subtracting a squared from both sides, then I would get b squared plus c squared minus a squared. And then I have my minus 2bc cosine a. And if you take a look at this, if I were to then take this statement and add it to my other side of my equation, and this would equal 0, by the way, but if I take this side and add it over here, then I would have, and I need to see there, 2bc cosine a, and then I would have 2bc cosine a is equal to b squared plus c squared minus a squared. And then I could divide by this statement, 2 times b times c, and then I'd be left with cosine a is equal to b squared plus c squared minus a squared divided by 2 times b times c. Now, depending on the given information, this form of the cosine law will be different, right? This is if we're looking for cosine a, but if we're looking for cosine b, then the only thing that's different is just how our A, B, and C values are organized. And so if I were to substitute the B out of this position, then I would have C squared plus A squared minus B squared divided by 2 times C times A. And so if we're looking for angle B, then we're subtracting side B and we're not dividing by B at all. So likewise with cosine C, this would become b squared plus c squared minus a squared divided by 2bc. Oh, sorry. This would be a squared, and this here would be c squared, and this would be ba. So last example we're going to look at today is class example number 6. Determine the largest angle in triangle ABC if A is equal to 14.7, B is equal to 8.9, and C is equal to 12.6. Okay, so if I have my largest side here is side A, and so we'll call that 14.7, and then I have, and so this would be A, and then I have side B here, which would be 8.9 centimeters, and so that would have to be B, and then I have C, which is 12.6 centimeters. And we want to determine the largest angle. And so the largest angle, if we look at, I didn't really draw this triangle properly, but we have two acute angles, and then we have this third angle here. And it actually looks like we have three acute angles. But anyways, this angle A looks like the largest one. So we're going to be looking for cosine A. Now to find cosine A, remember we have to go b squared plus c squared subtract a squared divided by 2bc, where we just have side lengths, right? So cosine A is equal to b, which is 8.9 squared, plus c, which is 12.6 squared, minus a, which is 14.7 squared, divided by 2 times 12.6 times c, which is, b times c, 12.6 times 8.9. And then we have to find the cosine. So I have, and again, we can do this in 2 steps is best. So 8.9 squared plus 12.6 squared minus 14.7 squared. And I end up with 21.88 on top, divided by lots of brackets, or just one bracket, 2 times 12.6 times 8.9. 0.097 is my answer there. So divided by this 2 times 12.6 times 8.9, I get 0.097. And that's my cosine ratio, right? So in order to find the angle A is equal to the inverse cosine of 0.097. So angle A is equal to 84 degrees.